Welcome, dear students. Our module 6 is numerical methods 2. And the first section is solution to linear system of equations. We have two different methods for solving system of equations. The first one is Gauss elimination method, which is a direct method, and the other one is Gauss Seidel iteration method. So we start with the Gauss elimination method. Here, consider a linear system of three equations in three unknowns x, y, and z. a1x plus b1y plus c1z is equal to d1. a2x plus b2y plus c2z is equal to d2. a3x plus b3y plus c3z is equal to d3. For solving this system of equation using Gauss elimination method, first we form the corresponding matrix form. The matrix form of this system is A1, B1, C1, that is the first entry is the coefficients of x, y, and z in the first row. And we form the corresponding coefficient matrices A1, B1, C1, A2, B2, C2, A3, B3, C3 into x, y, z is equal to D1, D2, D3. The corresponding matrix form of this system of equations. Here, A is called the coefficient matrix and D is a constant matrix. For solving the system of equation, we form a new matrix called augmented matrix, and that augmented matrix is AD. And this matrix is constructed by inserting a new column to the right side of the coefficient matrix A, and that column is the constant matrix D. So the augmented matrix is, first row is A1, B1, C1, D1, second row is A2, B2, C2, D2, and the third one is A3, B3, C3, D3. Now transform the augmented matrix to an upper triangular matrix by elementary row transformation. So we convert this matrix to an upper triangular matrix. So by using elementary row transformation, there is no change in the first row A1, B1, C1 and C1, D1. But the second row is changes to the first entry becomes 0, and using elementary row transformation, B2 changes to B2 dash, C2 changes to C2 dash, D2 changes to D2 dash. And the first entries in the third row are 0, that is A3 and B3 are 0. Then C3 becomes C3 double dash and D3 becomes D3 double dash. Now we form the corresponding system, corresponding matrix form from this augmented matrix, and it is A1, B1, C1, 0, B2 dash, C2 dash, 0, 0, C3 double dash into x, y, z is equal to D1, D2 dash, D3 dash. Then we find out the values of x, y, z from this reduced system by back substitution. In the same manner, we have to find out the solution of a system of equations in 4 unknowns and 5 unknowns, etc. The method will fail if any one of our A1, B2 dash or C3 dash become 0. That is, if any one of this A1 or B2 dash or C3 double dash is equal to 0. In such cases, we rewrite the equations in a different order so that A1, B2 dash or C3 dash are non-zero.